All right, so this is a little background for my subscribers. Thank you for watching. It was like 2 in the morning, and on my recommendation page, there was like this video of a high schooler explaining the fourth dimension. I was like, oh, that's kind of cool. Fast forward a few months, and my teacher, Mr. Duffy, was like, you guys are going to research a math topic. And everyone was like,
I'll take fractals.
good choice. And you, Chris?
Fractals?
How original. So I was looking at the list, and I saw fourth dimension. I was like, oh, I guess that'll be my topic. Okay, Chow and Quentin. I'll take Golden Ratio, and I'll take Fourth Dimension. All right, intro over. Time to actually earn a grade. So, a little background on the fourth dimension. The idea of the fourth dimension began with Aristotle and Ptolemy during the classic times, talking about the possibility that dimensions are more complex than just the third dimension. Centuries later, English mathematician John Wallis would also think of the possibility that there are higher dimensions than three, but they all had something in common. They all believed it wasn't possible. The idea would then be picked up during the French Revolution with D'Alembert and Lagrange, believing that the fourth dimension actually represents time. This is plausible as there are no other dimensions for space besides length, width, and height. The fourth dimension would also get more interpretations during the 19th century in spatial terms, being the result of the three-dimensional reflections. So, looking at both interpretations, let's first look at time. Popular physicist Albert Einstein believed that time is its own dimension, with space always involving time. You can't travel instantly. There will always be some extent of time to change your position on a spatial plane. So without the fourth dimension, there is no way to manipulate the dimensions below it on a vector. Now in spatial terms, here's where it gets more complicated. Okay, so say on a two-dimensional plane, there's a circle right here, and then a line right there, and then you are this dot right here. Yeah. So on a two-dimensional field, there's no looking past this wall. You can only see just this line. So to see past the line without moving, you would have to look at the line three-dimensionally to look over it to see the circle. But what does this have to do with the fourth dimension though? Well, look at this cube. Us with our three-dimensional minds can only see a maximum of three faces of the cube. If we wanted to see all the faces though, we would have to go up a dimension to see all the faces. That is what the fourth dimension accomplishes. Further details of the objects impossible for us to actually see. With the theories of what the fourth dimension would look like, mathematician Charles Howard Hinton would create the tesseract, a four-dimensional cube. First thing to be said is that the model of a tesseract is inaccurate. A cube has a length, width, and height all perpendicular to each other. A tesseract, however, has strength. Strength is the combination of length, width, and height, but perpendicular to it. The lengths in the tesseract are also equal, but the model shows a smaller cube in a larger cube. It's just an illusion, as you can see it changes as it rotates. Yeah, I have no clue how it works, but neither does anyone else. We can't see the fourth dimension because we live in a 3D world with only 2D vision. So, what does the fourth dimensional theory mean for us in the future? Honestly, I have no clue. I saw something about like teleportation, but like it's kind of like nah. And then a bunch of other dimensions going higher. I don't even know what that means, but hey, I just researched the fourth dimension. So, Duffy, 100, and yeah. Oh, and if you thought I wasn't gonna plug the YouTube channel in a calculus class, you're crazy.